Hello everyone. So, today we are going to study about linear data structure, in that specifically array. Previously we have studied primitive data structure, non-primitive data structure, linear data structure, non-linear data structure, all these things we have studied in the previous video lecture, and today we are going specifically for the array. So, what we have? So, array, first of all, what is an array? So, you might have studied this in the first year. So, that array is a collection of elements of the same data type, right. So, we can consider it as a container, right. So, here we have a container where we can store multiple data, right. You can like it vertically or horizontally, right. We can consider it as a container that is having a multiple data storage, right. So, we can store the data like suppose like 3, 4, 5, 7, 9, right. Here also I can store data, right. So, what that array have usually that always array can be accessed with the use of index, right. So, what is an index? So, index, that is a subsequent number that we use to indicate that, right. So, here we can have it usually starts with 0, right. Our array usually starts with 0. So, 0, 1, 2, 3, 4, right. So, this array is having a size 5, right, size of 5, and it start with the 0 and 4, right, 0, 1, 2, 3, 4. Similar way, this is having a size 4. So, 0 to 3, right. So, this is an array, right. Now, this concept you have already studied, but what we are going to study today, that in a memory location, like in a physical memory, how to store this data, like actually it is stored automatically, but in which way it is stored, right. So, as you know that in memory we have particular locations, right, and in that location this data is going to be stored, right. So, like let us say we are having a location 1011, 1012, 1013 and so on, right. So, at which location this data are going to be stored, and if I want to access a memory location of a particular index data, let us say of this 5, right. So, how can we store it? Right. So, that things we are going to study today, and one more thing, that's consecutive memory location, right. So, in a memory, in a physical memory, all your array elements are stored in consecutive manner only. That is the most important thing, that it is a linear data structure, and in that linear data structure it is stored in a consecutive manner, right. Now, here are the types of the array we are having, that is a one dimension array, two dimension array and a multi-dimension array, right. So, first we will see what is one dimension array. So, as you know that one dimension array, that is having only a single vector, right. So, we can consider it likewise this. Here we have 0, 1, 2, 3 and 4, right. So, it is a one dimension array that we can store only one one vector data, right. So, the what is this? This is the define, how we can define structure, right, how we can define an array, right. So, first that is a data type, then array name and a size, like. So, if I want to store the data that is of integer data type, right. So, I need to write int, that is integer data type, then array name, let us say my array name is a, right. So, integer a, and in a square bracket I need to write the size of it. So, here I am having the size 5, so I can write 5, right. So, this is the initialization, so integer a 5, right. Now, how can we find the address of that element? Because in a physical memory, this is the logical part, right, that we use, this is the logical part. Now, in a physical memory location, like suppose here we have a data 2, 7, 9, 11 and 13, right, we have a data. Now, I want to store it in a physical, right. So, here suppose we are having 1011, 1012, 1013, 1014 and 1015. So, my 2 will be stored over here 7, 9, 11 and 13, right, in this way, right. Now, if I want to find a memory location of a particular data, because this is the insight work, right, your computer knows this, you do not know this, that at which location. So, if I want to find a particular location of, so let us say for this 11, right, we know that it is stored at the index 3, right, but you do not know at which actual memory location, physical memory location it is stored. So, if you want to find that, here is the formula, that is A of I, that is equal to B plus W into L I minus LB, right, where what is B? So, B is the base address of the memory. Now, what is base address? That means if I am having this array to be stored in a memory, so it is starting from this 1011. So, for this example, this 1011, that is the base address of the array, right. Now, W. What is W? So, W is the size of each elements in a bytes, right. So, how many elements per memory word you are storing it? It can be 1, 2, here we are having integers. So, we can say that 2 byte per memory word, right, it is storing. So, W is 2 for this, right. So, here we can have it is a 2, right. Then I is the index of an element whose address to be found, right. So, here we are finding it for the 11, right. So, what is the index for that 11? That is a 3, right. So, here I is 3, right, and LB is the lower limit, that is a lower bound we are having, right. So, in this we are not having any lower bound. So, if you are not given any of the lower bound, you can initialize it with 0. Right. So, these are the terms, right. So, you can find, like if I want to find for this third location. So, I can write that B, that is 1011 plus W. So, here in this example I have used in only one byte per memory word, right. So, here we have 1 byte. So, 1, right, in a bracket what we are having I minus LB. So, I, that is a 3 minus LB, nothing is given. So, initially it is a 0, right. So, it is a 1011 plus 3, that is 1014, and yes, you can see it is stored at 1014 location, right, getting this. So, this is how we can find the actual memory location of one dimension array, right. Now, we move ahead with the 2 dimension array, right. So, 2 dimension array is simple, you can consider it as a matrix. Matrix is a 2 dimension array, right. So, again the same data type, array name, then the row size and the column size, right. So, I can have, if I want to have a integer data, so I can have integer, right, and suppose I am taking M, that is for the matrix, you can take any name for that, right. Then suppose I am having 10, that is my row size, and column size, that is a 5. So, I can have 10 rows and 5 columns, right. So, this is a 2 dimension array, right. Now, you might face this question, like it might be a click, that if I am having this 1 dimension array, then it is easy that you know that it is stored in a sequence, that first element is stored at 1011 location, second element is stored at 1012 location, and so on. Now, in this matrix, suppose let me take a 3 by 3 matrix, right. So, suppose I am having a 3 by 3 matrix. So, here I am having a value 3, 4, 5, 7, 8, 9 and 1, 2, 3, right. So, I am having this 3 by 3 matrix, right. Now, in this 3 by 3 matrix, if I want to store this data in the actual memory location, how can I store it, right. Whether I need to go row wise or I need to go column wise, in which way I need to go, right. That is a question it might arise to you, right. So, there are 2 methods, that is a row measure method and a column measure method, right. 2 methods we are having, row measure and column measure method, by which you can store a data in an actual memory, right. So, you can consider like this is your rows, right, row 1, row 2 and a row 3, right, row 1, row 2 and row 3, and here we have a column, that is column 1, column 2 and column 3, right. Now, if we want to store a data in a row measure method, so like we have it over here, that here we have 3, 4, 5, 7, 8, 9 and 1, 2, 3, right. So, this is 1, 2, 3, 1, 2, 3. These are your rows and these are your columns, right. Now, if I want to store this data, now if I am having like memory location over here, right, I can have a multiple memory locations, So, let us say it is starting for 1021, 1022, 1023 and consecutive memory locations we are having, right. Now, if I am using row measure method, if I am using row measure method, right. So, in a row measure method, what we need to do? We need to go row wise. Row wise, that means first we need to complete the first row, then we need to complete the second row and then we need to complete the third row, right. So, in a first row, this first element 3, that is going to be stored over here, right. Then the next element, that is 4, that is going to be stored over here, right. Then the next one is the 5. So, 5 is going to store over here, similar way 7, 8, 9 and 1, 2, 3, right. So, this is using row measure method, right. Now, if I want to use a column measure method, right, if I want to use a column measure method, so we need to consider first of all the columns, right. So, we need to go in this manner, first we need to complete this entire, then we need to go for second row and then we need to go for the third row, right. So, in a column measure method, it can be stored like this 3, 7, 1, 4, 8, 2, 5, 9, 3. So, this is a column measure method, right. So, in a physical memory, these two ways are there to store a 2-dimension array, right. Similar way for the multi-dimension array also we can use these two methods only, that is a row measure method and a column measure method. Now, this is just storing idea, that how can we store this, right. Now, if I want to find that at which particular location, similar like previously we have find for the 1-dimension array, right, that at which location, particular memory location that data is stored, right. So, the same thing if we want to do for the 2-dimension array. So, here we have a two different formula, one that is for the row measure method and the another formula that is for the column measure method. So, first we are considering the row measure method, right. So, what is the formula? That is Aij, I that is a row number, j that is a column number. So, Aij that is equal to b plus w into n, and that is a number of column, right. Multiply with I minus LR plus j minus LC. LR that is a lower bound of a row, LC that is a lower bound of a column. If it is not given, you can consider it as a 0, right. Then B, as you know, that is a base address from where we are starting our storing, like base address, the first data that is going to be stored at that particular location. W that is memory per bytes of memory per word in a bytes, right. Then LR that is a lower limit, LC that is a lower limit of column, then INJ that is a number of row and number of column. Now, we have a column measure method, right. We have the column measure method. So, it is the same, almost the formula is same, the only difference is the formula is here, instead of usually we have previously we are having n into, right. So, that is for the row measure method, right, because we are considering the row measure method. So, we need to multiply the number of columns with the I, right. Here we are considering the column measure method. So, we need to multiply the number of row with the column, that is j, right. So, here we have A of ij that is equal to b plus w into I minus LR plus m into j minus LC, right, where all these things you know that b is the base address, w that is a storage size of an element, right, it is like a memory per word, right, simple. I that is a row, number of row for which you are finding it, right, j that is a number of column, LR and LC that is a lower bound, right, usually if it is not given you can consider it as a 0, right, and the next INJ that is a number of M that is a number of total number of column, the size of the column, right. So, that we have, right. So, again the same example, right, x of 15, 20 we need to find. So, simply what we need to do, that is a 1500 because our b is 1500, w that is we are having 1, right, I. So, I what is my I, that is a 15 minus LR that we consider at is a 0 plus M. So, M what is my M? So, M is 30, right, because M is a number of row, right. So, that is a 30. So, we are considering this, right, and j minus LC. So, j, that is your, what is your j, that is 20 minus 0, right, and you can solve it out this example, and whatever answer you get, that is your particular memory location of that x 1520, right. So, that is about how to find a memory location. Now, we are having application of array. You all might knowing this application of array. So, array usually used in mathematical problems, right. For the matrix, sparse matrix you are having, and all this mathematical computations, right. For that we can have this. Then next, to implement the data structure, most important, that we are having this data structure array, but to implement the higher data structure, for example, trees, for implementing the linked list, right, that kind of data structure we are going to use this array, right. Then for the database records, for that purpose also we can use it, right, and it is used for lookup tables, right. There are like number of applications of array, right. So, here's are the applications of array, and that is all for this lecture, right. So, what we have studied is what is an array, right, types of array, then how to store it, row measure method, column measure method for the 2-dimension and multi-dimension array, right, and how to find the particular memory location for that, right. So, that is all for array in this lecture. In the next lecture we are going to study about the stack, right. So, thank you very much. Bye bye.